The topic of our lecture today focused methods. After this lecture, you will be able to evaluate the relationships between two variables and to predict values of one variable for given values of another variable. In general case, focused or prediction is a statement about an uncertain event. It's often, but not always, based on experience or knowledge. Problem of our lecture today: prediction using statistical methods. We will discuss this problem. Use next example. Total cholesterol level prediction for a given age. Point of our interest: strength and direction of the association between age and total cholesterol level. Predicting values of total cholesterol level for given values of age. For this task, we randomly select 18 female. You can see age of these women and their cholesterol level. The younger woman was 22 years old and the elderly woman was 63 years old. Here you can see that the data are presented on this scatter plot, and black dot it's each woman age and total cholesterol level. There are 18 black dots. The pattern of the data is indicative of the type of relationship between two variables. And there are two types of relationships: monotonic and non-monotonic. In a monotonic relationship, the variables tend to change together, but not necessarily at a constant rate. In non-monotonic relationship, two variables are associated, but only in a very general sense. The presence or absence of one variable is associated with the presence or absence of another. How can we measure the nature and strength of an association between two variables? We can perform a correlation analysis or correlation coefficient calculation. Here you can see two different types of correlation coefficient. It's Pearson correlation coefficient or product moment correlation coefficient, or Spearman's rank correlation coefficient. The Pearson correlation evaluates the monotonic linear relationship between two continuous variables. In the linear relationships, a change of one variable is associated with a proportional change in the other variable. The Spearman correlation evaluates the monotonic relationship between two continuous or ordinal variables. After coefficient correlation calculation, we can do conclusion about association nature and association strength. The sign of correlation coefficient denotes association nature. If the sign is positive or greater than 0, it means that relation is direct. An increase of one variable is associated with an increase of another variable, or a decrease of one variable is associated with a decrease of another variable. You can see it on A and B graph. Here you can see positive relationship. If the sign is negative, it means are less than 0. It means an inverse or indirect relationship. An increase of one variable is associated with a decrease of another variable. You can see this relationship, negative relationships, on D and E graph. And graph C, there is no relationship. The value of correlation coefficient denote association's strength. It can be weak, moderate, and strong. If correlation coefficient is from 0 to 0.25 or from 0 to minus 0.25, it's weak correlation. If between 0.25 to 0.75 or minus 0.25 minus 0.75, it's moderate correlation. And if correlation coefficient is from 0.75 to 1 or minus 0.75 to minus 1, it's strong correlation coefficient. And if correlation coefficient is equal minus 1 or 1, it's perfect correlation. And here was calculated correlation coefficient for our example. It's equal 0.937. It's positive and strong. And we can do next conclusion. Very strong and positive direct association between age and total cholesterol level. And total cholesterol level increase is associated with age increase. How can we predict values of one variable for given values of another variable? We can perform a regression analysis. And today we will discuss simple linear regression. It concerns two-dimensional sample points with one independent variable and one dependent variable, and define a linear function that predicts the dependent variable values as a function of the independent variables. You can see here regression equation: x independent variable, y dependent variable. A intercept indicates the location where the line intersects an axis, and B slope or gradient indicates the steepness of the regression line. Here you can see how you can calculate slope and intercept. First of all, you can measure initial data for independent and dependent variable, then calculate mean, and then use this equation, calculate first of all B and then A. Here you can see example regression equation. For this equation, the slope is positive equal 5. It means when x increases by 1, y increases by 5. And you can see here intercept equal 2. Next example, the slope is negative minus 0.4. When x increases by 1, y decreases by 0.4. And intercept here is equal 7.2. On this example, slope is equal 0. It means when x increases by 1, y never increases or decreases. And here you can see intercept equal minus 4. Getting the estimates of A and B means finding the best straight line that can be drawn through the scatter plots of x versus y. And the least square regression line is the line that makes the sum of the squares of the residuals as small as possible. Residuals is the difference between the actual data and the predicted values. And you can see here the residuals is the vertical lines between dots and the regression line. How we can predict? For our example regression equation, total cholesterol level equal 1.089 plus 0.058 multiply H. H independent variable, total cholesterol level dependent variable. If a patient, for instance, is 45 years old, the predicted value of total cholesterol level will be 3.12 milligram by milliliter. And you can see here how we can calculate it. Next example, if a patient is 60 years old, the predicted total cholesterol level will be 4.57 milligram by milliliter. And you can see here that the black dots is actual data and the two red dots on line, it was predicted value of total cholesterol level on given age, 45 and 60 years old. Next step in regression analysis, we can calculate the determination coefficient. It indicates how well the model, in our case least squares regression line, fits the data. These coefficient values are between 0 and 1. The closer r square is to 1, the better the regression line explains the response. R square gives a fraction of the variability of y that is explained by the least square linear regression on x. In our example, correlation coefficient was 0.937. Then r square determination coefficient equal 0.878. It means that 87.8% of the total variation of cholesterol level values can be explained by its linear relation to age, and another 12.2% of the total variation in the cholesterol level remains unexplained. And in conclusion, we can repeat the next step which you have to do for prediction using statistical method. First step, define variables. Second step, draw the scatter plot. Third step, correlation analysis. And the fourth step, regression analysis. For more information about prediction, correlation and regression analysis, you can look next references. And thank you for your attention.